In this video, I introduce a batch normalization in artificial neural networks. Layer input changes with the parameters of the previous layer, which makes the network training complicated. For example, requires more learning rate that slows down model training. For example, a sigmoid activation function sigma has a derivative of sigma times 1 minus sigma. When input x value increases, sigma tends to 1, and his derivative tends to 0, namely stop learning. Batch normalization is a technique to reduce the saturating problem, which stabilizes the input to activation function to reduce the chance of optimizer getting stuck in the saturated modes, so that a larger learning rate is used in model training. Internal covariate shift indicates a parameter variation of layer input during model training. If input x has a distribution with a mean 0 and covariance 1, the model training will converge fast. Batch normalization uses the mini-batch mean and covariance as a reference to normalize each layer input. Stochastic gradient descent method is used to train deep neural networks by minimizing the loss error. The descent direction is determined by all samples xi in mini-batch, as shown here, where sigma star is optimal model parameters, and m is number of training samples in a mini-batch. Here we introduce two types of batch normalizations. The input to the model is a mini-batch that includes M images. In a regular neural network, convolution is conducted on the output of layer L to generate input to the activation function in the layer L plus 1. Now we insert a batch normalization between layer L and layer L plus 1. We first use convolution on the output of layer L to generate x1, xi to xm. And then we extract mean and covariance from x1 to xm. And then we use this mean and covariance as a reference to normalize x to x hat. And then we use gamma and beta to transform x hat to y. That is used as an input to activation function in layer L plus 1. The popular batch normalization is first to extract mini-batch mean and covariance from output of layer L. And then we use this mu and sigma square as a reference to normalize x to x hat. And then we use gamma and beta to transform x hat to y. That is used as input to this convolution. And then the result from convolution is used as an input to activation function. Batch normalization procedure is listed below. First, extract mini-batch stochastical characters, mu and sigma square from the output of the previous layer. And then normalize each feature in the mini-batch, use mu and sigma square as a reference. Finally, using learning parameters gamma and beta to scale and shift the input to the activation function in the next layer. Details are shown here. For more details, please check with these references. Thank you. Bye.